Welcome back to the course on sustainable aviation. Today we will look at elements of propulsion system. So let's get started. So when we talk about propulsion system, what do we mean actually? It's not only the engines, or it's more than that. So there are three main elements of a propulsion system. The first one is the energy source. We need to carry energy on board in order to create thrust. But before that, we need to convert that energy into work. So we also need an energy to work converter. And then we need to convert that work into thrust. Let's look at this more in detail. But all these elements of propulsion system should work along the constraints of the aircraft and the constraints of the mission, the regulations, and so on. So let's get started to look at the different elements. We already looked at the last lecture, how can we create thrust? So for example, by using a propeller or by a nozzle, that we demonstrated with our balloon experiment. In terms of energy sources, we could use different types of energy sources. And one way of classifying these energy sources is to look at the energy density, which means the amount of energy that we can pack in a given mass of that source. So for example, when you look at electrical batteries, we can have different types of batteries, and each type of battery has a different energy density. Kerosene, which is used typically for civil aviation, has a pretty high energy density of approximately 43 megajoules per kilogram. Nowadays, there is a lot of discussion going on about hydrogen. Hydrogen has also a very high energy density, and that is approximately around 120 megajoules per kilogram. Of course, the ultimate energy source, in a sense, is to look at nuclear fuel, for example, uranium, which has a far more higher energy density. However, we don't use nuclear fuel because of safety concerns and so on and so forth. But nevertheless, just after Second World War, both Americans as well as Russians tried to make nuclear-powered aircraft. Now, one way of classifying these energy sources was to look at energy density. We could look at mass energy density as well as volumetric energy density, because both mass as well as volume are very, very important for aircraft. We would like to have very high energy density, mass energy density, and very high volumetric energy density. On this chart, you will see different energy sources and the associated mass energy density as well as volumetric energy density. So if you would see hydrogen, for example, which has very high mass energy density, but poor volumetric energy density, if we liquefy it, then we can increase the volumetric energy density of hydrogen, but still not as much as kerosene. Batteries, on the other hand, are on the lower left corner because their mass energy density as well as volumetric energy density is pretty low. Kerosene, along with other hydrocarbons, can have decent mass energy density as well as volumetric energy density, and that is one of the reasons why we use it in civil aviation. Now, just for the sake of fun, I put peanut butter, which I eat almost every day. It also has quite high energy density. Now, one of the things that we should keep in mind when selecting different fuels is the fact that if the mass energy density is less, then the amount of energy source that needs to be carried on board increases, which means the mass increases, which means that the lift that should be generated by the wings, that increase, which means that the drag increases, which means that the thrust produced by the engines increase, and so on and so forth. So this is what we call as the snowball effect. So that's why we have to be very careful when selecting different energy sources for the aircraft. Now, once we select energy sources, so let's see how can we convert that energy into work. We use these engines all the time. So for example, the internal combustion engines is used in many of the cars. Electrical motor is also used in the cars, but also other appliances, home appliances, and so on and so forth. And again, one way of classifying these different energy to work converters is by looking at their power density, which means that how much amount of power can this equipment generate per unit mass of that equipment. And I have given some typical numbers for these different equipments. Fuel cell itself is not converting energy into work, but nevertheless it converts one form of energy, which is chemical form of energy, into electrical form of energy. Electrical motors and Wankel engines are rotary engines. When you look at a gas turbine, then you can see that the power density of a gas turbine is much higher as compared to other equipment, and that is why typically for aircraft, gas turbines are used. Now, we have looked at different ways of producing thrust, different energy sources, and different energy to work converters. Now, depending on the aircraft type and the missions and the constraints, we can do selection of different sources. So, for example, if you are designing an unmanned aerial vehicle, you could use batteries with electrical motors and with propellers. Or for general aviation aircraft, you could use kerosene or F-gas along with reciprocating piston engines with propellers. You could also use high energy density batteries with electrical motors and propellers for some of the electrical aircrafts. For civil aircrafts, typically we use kerosene with gas turbine and a combination of propeller and nozzle, which is called as the turbofan engine, as the element of propulsion system. So you can make your own selection depending on the mission. Here is an example of an electrical propulsion system. So what you see here, the energy source is a battery, the motor converts that energy into work, and the propeller produces the thrust. Let's take a look at it. How powerful is a jet engine? So if you are driving a car, typically your car might have around 150 to 200 kilowatts of power. And if you have a very fancy car, typically that happens with people going through midlife crisis, then you see a powerful car like Ferrari. It might have power around 500 kilowatts or so. But when you talk about a jet engine, typically the power that is generated by a jet engine is in several megawatts. I have given here some numbers for comparison. And that is why we use jet engines in civil aviation.